Hello students, welcome again. As far as this e-class or e-learning is concerned, we are continuing the topic carbon and its compounds. Last time we were talking about versatile nature of carbon. Versatile nature of carbon by discussing the subtopic of carbon's compounds, versatile nature of carbon. And I told you people carbon is having two important properties, two important characteristic properties. That's property of catenation and another is property of tetra valency. We discussed the catenation in brief as far as this last video lecture is concerned. And I told you people in previous lecture that it is this property of catenation which enables the carbon to form millions and trillions of the compound, and we have discussed this very property briefly. Now we will take another property, that's property of tetra valency. Tetra valency. Before discussing tetra valency, let me remind you people what actually valency is. In metals and non-metals, I gave you the brief introduction or rather brief description regarding this valency, and let me recapitulate certain important points as far as this valency is concerned. Valency is actually combining capacity of an element. Combining capacity of an element or its ability of an element to lose or gain electrons to complete their octet. That is, to achieve stability or to achieve nearest noble gas configuration. Tetravalency. Before discussing tetravalency, what's valency? Valency is actually combining capacity of an element or its ability of an element to lose or gain electrons to complete their octet. That is, to achieve stability. I told you people that it's actually stability which enables an atom to lose or element to lose or gain electrons. Now, because why atom loses or why the element loses electrons or gains electrons, it's because to complete their octet or to achieve stability or to achieve nearest noble gas configuration, and then only an atom or an element becomes stable. It's because of this property of tetravalency carbon forms millions and trillions of the compounds. Let me give you brief description regarding this tetravalency. It is this property, it's this characteristic property, carbon forms millions and trillions of the compounds, and I told you people nearly 5 million organic compounds are known, and it's because of these two properties, catenation and tetravalency. Now, tetravalency, as far as carbon is concerned, carbon is having atomic number of 6. That means in its first shell it contains 2 electrons, in its second shell it contains 4 electrons. Rather, in K shell it contains 2 electrons, in L shell it contains 4 electrons. Now, carbon has to lose these 4 electrons or it has to gain 4 more electrons to achieve nearest noble gas configuration or to complete its octet. Because I told you people, according to octet rule, an element should contain 8 electrons. I can say 8 electrons in its valence shell. And as far as this, I told you people that why element loses or gains electron, because to achieve nearest noble gas configuration. And I told you people regarding these noble gases are stable at their room temperature. For example, this is helium, this is neon, this is argon, and this is krypton, and this is xenon, and this is radon. And that's why you people will see these elements in the separate group of the periodic table, 18th group elements or 0 group elements. That's why they have been placed in the separate group as far as periodic table is concerned, because of their stability, because they are stable at their room temperatures. So they neither lose electrons nor they gain electrons. It's because their octet is complete. They follow actually the octet rule. And I told you people, as far as this carbon is concerned, carbon is having valency of 4. And because of this 4 valency, it's also called as tetravalency. Tetravalency, because carbon is tetravalent in nature. Tetravalent means it's having 4 valencies. And these 4 valencies actually enables the carbon to share with other atoms, and those atoms may be similar, means it can form bonds with other carbon atoms, or it can form bonds with oxygen, carbon, it can form bonds with nitrogen, it can form bonds with chlorine, it can form bonds with hydrogen, it can form bonds with sulfur. And according to the Liebel and Van 't in 1874, they said in their statement that as far as this carbon is concerned, this carbon is tetravalent in nature because it's having 4 valencies. It's like this. This carbon is atomic number 6. In first shell it contains 2 electrons, and in second shell it contains 4 electrons, and these 4 electrons, 4 valence electrons, because these valence electrons are those electrons which are present in the last shell, and it's these 4 valence electrons which defines the valency of the carbon. And these valencies, carbon always forms bonds, and these valencies carbon shares with other atoms. I told you it can form covalent bonds with carbon as well, it can form covalent bonds with oxygen as well, with chlorine as well, with nitrogen as well, with sulfur as well, giving rise to the enormous number of organic compounds. And because of this property of tetravalency, carbon forms millions and trillions of the compounds. Now, according to the Liebel and the Van 't, they said that these 4 valencies of the carbon, this is carbon, central atom, and having 4 valencies, and they said these 4 valencies are directed towards the 4 corners of the regular tetrahedron, giving carbon a tetrahedral structure with angle equal to 109 degrees 28 minutes. Let me recapitulate this. As far as tetravalency is concerned, tetravalency is actually the property of the carbon. Because of this property of tetravalency, carbon forms millions and trillions of the compounds. Before discussing tetravalency, I told you people that valency is actually combining capacity of an element. Combining capacity of an element, or its ability of an element to lose or gain electron. If somebody will pose you a question, why element loses or gains electron? It only loses electrons or gains electron to achieve nearest to noble gas configuration, because noble gases are stable at their room temperatures. And same is the case with this carbon. Why carbon is tetra? Tetra means it's having 4. Valency means combining capacity. Tetra means 4 valencies, because it's having 4 electrons in its valence shell, and it shares these 4 electrons with other atoms like with similar atom as carbon, with homoatoms. It may be homoatomic, it may be heteroatomic, means carbon can form bonds with other atoms as well, like oxygen, like chlorine, like hydrogen, like sulfur, giving rise to the enormous number of carbon compounds. And these 2 properties, catenation and tetravalency, carbon forms millions and trillions of the compounds. And as far as carbon is concerned, it's having 4 valencies. I told you people in the previous lecture, neither it gains electrons, neither it loses electrons, nor it loses electrons, neither it loses electrons nor it gains electrons, because these electrons are tightly bound to the nucleus, and it always shares these 4 electrons, giving rise to an enormous number of the compounds. And according to Liebel, which describes the structure of the carbon, and they said that in their statement that these 4 valencies of the carbon is valency number 1, valency number 2, and valency number 3, valency number 4. And these 4 valencies are directed towards the 4 corners of the regular tetrahedron, giving carbon a tetrahedral structure with angle equal to 109 degrees 28 minutes. Hope you people have got this, and in next lecture we will discuss the allotropes of the carbon. Thank you for watching this, And if any student having any sort of the queries as far as this online lecture series is concerned, he or she can contact me on 7006202366. Thank you for watching this.